You know, every single time you get in a car, you're placing your trust in this invisible system. It's a really complex language of rules, materials, and tests that turns a simple road into an absolute marvel of engineering. Today, we're going to decode that language. We're going to pull back the curtain on the incredible science that keeps all of our journeys safe. And this is our guide. This is the official highway design standard from the Sultanate of Oman. Now, I know it might just look like some dense government document, but trust me, inside this thing is a universal blueprint for building infrastructure that can pretty much withstand anything. It's the instruction manual for the world that exists right underneath our wheels.
So where does a massive project like this even begin? Well, before a single shovel ever hits the dirt, it all starts with a plan. And I'm not talking about a sketch on a napkin. I'm talking about an intensely detailed set of working drawings that dictate every single millimeter of the project.
Okay, now take a look at this, because this is where it gets really cool. On the left, you see the structure, right? A simple retaining wall. But on the right, you see the language that actually brings it to life. Every single line, every curve, every angle on that drawing corresponds to a very precise number in those tables. It's not just a picture, it's a set of commands. And this right here? This is the golden rule. Nothing gets built, nothing is even ordered, until the head engineer has personally signed off on that blueprint. What this means is that this planning phase is totally non-negotiable. It is the absolute foundation of quality, and of course, safety. All right, so the blueprint is approved. Let's talk about the stuff they actually build with. You know, we tend to think of concrete as this simple, boring material. You just mix some stuff together and pour it. But in reality, it's a high-tech material with a very specific secret recipe. And that recipe changes completely depending on the job. And the key ingredient, the one thing that can make or break the whole recipe, is the water-to-cement ratio. It sounds almost too simple, but getting this number exactly right is one of the most critical parts of the entire process. It determines the final strength, the durability, basically how long this thing is going to last. So for example, let's say you need concrete that won't let any water seep through, what engineers call low permeability. For that, the recipe calls for a water-to-cement ratio of exactly 0.45. But what if that structure is near the ocean, where it's going to be constantly blasted by corrosive saltwater spray? Well, the recipe gets even stricter. The ratio drops to 0.40. You need less water to create a denser, tougher shield for the steel that's reinforcing it from the inside. And what if the big threat comes from chemicals that are in the soil, like sulfates, which can literally eat away at concrete over time? Yep, you guessed it, you need another specific recipe, this time with a ratio of 0.42. Every single threat has its own custom-designed defense. And this slide really breaks down the trade-off. See, using more water makes the concrete way easier to pour, which is convenient. But as it dries, it creates these tiny little pores, leaving it weaker and way more vulnerable. Using less water? Well, that makes it incredibly strong and dense, the perfect armor for the absolute harshest conditions. Okay, so the blueprint is approved and the concrete recipe has been perfected. Now it's finally time to build. And the way modern structures get their incredible strength is from a steel skeleton that's hidden deep inside that concrete. But here's the thing, it's not just a passive frame just sitting there. Engineers use these really advanced techniques, like post-tensioning and grouting, to actively tighten that skeleton. Think of it like tuning a guitar string. They pull these steel cables incredibly tight and then lock them in place, which puts the concrete under constant compression. This makes the entire structure way, way stronger before it ever has to carry a single car. And the level of detail they have to go into here is just staggering. I mean, this is just a partial list of what's required for just one grouting operation. They have to submit the names and the experience of every crew member, have backup equipment on standby, and even have a pre-approved plan for what to do if the grout tube gets blocked. Every single possibility is accounted for. Now, once the core structure is actually up, the work is far from over. Now comes the armor, a whole series of protective layers designed to make sure the structure lasts, not just for years, but for generations. First up is the structure's very own high-tech raincoat. A special waterproofing membrane is applied to keep every last drop of water out, and the rules for this are strict, right down to the millimeter. If this membrane gets damaged, for instance, any patch they apply has to extend exactly 300 millimeters beyond the tear. That's how precise it is. And to make sure everything dries just right, especially in really hot weather, engineers use this fascinating and surprisingly low-tech solution. They literally fill a simple cake pan with water, place it next to the site and weigh it every 15 minutes. The weight loss tells them exactly how fast water is evaporating from the area. Absolutely critical data that they gather with, basic kitchen supplies. The protection is total. I mean, any exposed metal is coated with a special zinc-rich paint that actually meets U.S. military specifications. We are not talking about regular paint here. This is industrial-grade armor, designed for the most extreme environments on the planet. So, we've had the plan, we've got the recipe, we've gone through the construction. But after all of that work, the biggest question still remains. Is it actually strong enough? Well, it's time for the final exam. And the standards for this final inspection are absolute. If a sensor finds that the protective layer of concrete over that steel skeleton is even a little bit too thin, the contractor has to tear it all out and do it again, completely at their own expense. There is absolutely zero tolerance for error. But okay, after all the tiny details are checked and double-checked, how do the engineers prove that the entire massive structure is safe as a whole? How do they really know it can handle the stress of thousands and thousands of vehicles day in and day out? The answer is the ultimate real-world test. They conduct a bridge loading test. They literally drive fully loaded trucks onto the structure and measure exactly how it bends and flexes under that immense weight. A whole network of sensors records every single micro movement, confirming that the bridge is performing exactly the way the blueprints predicted it would. So, the next time you're out driving, just take a second to remember the hidden language that's right there underneath you. It's a story written in engineering drawings, in precise concrete recipes, and in military-grade paint. It's this entire incredible system of meticulous, invisible rules, all designed for one very simple purpose: to get you home safely.